So guys, in the previous class we have seen what do you mean by a good relational database, and for that we have seen various kind of features, right? So among those, one of the feature is efficiency, scalability and robust. Similarly, we have gone through what do you mean by a bad relational database schema, which contains redundant data as well as anomalies, and it may lead to lossy decomposition, right? So like this we have seen various kind of features with respect to a good relational DBMS as well as bad relational database. Okay, and also we have seen the various kind of guidelines, right? We can generally call it as informal guidelines because with help of basic illusion only we can able to define. That's why we say that like those are informal guidelines. Means something like we should not allow maximum extent null values, and inner things are there, right? Whatever the names that you are going to give for the attributes or for the table names, those should be meaningful names. So like that we have seen various kind of informal guidelines, right? Fine. So and also for all these things, the explanation is based on one single table, that is serial ID, student name and student department and the respective HOD and the respective phone number. Right? Guys, try to observe. If I am going to have student ID 1 whose name is J, department is CSC, HOD name is A, phone number is 4321. Similarly, 2K mechanical S 1234 3, and there may be two student names with the same name, right? So I am taking they are both from the same department and that too from the same section if you assume, and their HOD is same. HOD and phone numbers are same, right? Now if you are able to observe here, this data is duplicate data. So that's the reason we said that this is a kind of bad schema, because it contains duplicate data first thing. So for this reason, in order to avoid the duplicate data and in order to make the conversion of bad relational database to good relational database schema, we said we have to follow various kind of concepts. Among those, one kind of concept is functional dependency concept. Guys, here what do you mean by functional dependency? See, if you are able to observe this particular schema, if I am going to give student department number, like department name if I am going to give, can you able to define the HOD name? Because HOD is same for the same department. If I say that for the CS department, HOD is same. For the same department, phone number is same or not? Yes. So if I am going to take the mechanical department, HOD is yes always, right? So then why we need to mention all the data, similar kind of data here itself? That's the question, right? So to identify this, basically with our illusion, we can able to define it as student ID, student name, student department number, and also we can split like this: student department, HOD and phone number. Okay, so this is as with our illusion we can able to define, but there are certain situations where you cannot able to identify like this. So at that situation we have to go for compulsory functional dependency. What does the meaning of functional dependency means? If I am saying that student department derives HOD, so I can say that these two are functional dependency. What is the meaning of this one? Student department, S department can derives HOD, means if I am going to give the CSC as input, can you define the HOD name? Yes, the name is A. If I give the input as mechanical for the department name, can you tell the who is HOD? Yes. So I can say that student department name can derives HOD name. Can I write the another one? If I give student department name, can you derive phone number? Yes, I can derive the phone number. Or phone number is functionally determined by student department. I can call like this, right? But the case is, so I can call this as a functional dependency, and this also I can call it as functional dependency. Let me tell one more functional dependency. Student department derives student name. Is it the correct one? No, it is not correct. What is the reason it is not correct? If I am going to take student department CSC, it is going to derive many names, right? It is going to derive one J here and here also. Like assume that here, let me take some name as M also, M. And in this case, here if I am going to give CSC, it is going to define the student name as J. In this case, if I am going to give CSC as input, it is going to determine M. So that means that student department name cannot define the student name. So I can call it as student department doesn't derive student name. Right? If you would like to see it in terms of technical definition, if I am going to take the tuple T1 of an attribute S department, and trying to take the tuple T2 of the S department, if these two are same, right? I am trying to say if condition. If these two are same, then if I would like to say S department derives HOD, then T1 of HOD is equal to what? T2 of HOD. Then only I can say that S department derives HOD. So this is the definition of functional dependency, right? If you are able to observe here, right? So the meaning here is, if I am going to take the T1 of department, the value is CSC, and what about T1 of HOD? A, and this is CSC. And what about T2 of S department? CSC, right? If I say that these two are same, and if I want to say S department derives HOD, compulsory these two should be same, right? So now T2 of HOD is A. If I say that these two are also same, then I say that S department derives HOD, right? Take out the case for the S name. So for example, in this particular case only, in this particular case is SID functionally determines S name. Yes or no? Yes, I can simply say that, see, as these are all unique, I don't need to check again the right hand side property. When we need to check the right hand side property, if it has to be duplicate values on the left hand side, then only you have to check for the right hand side, right? As there are no duplicates, then no need to check for the right hand side, because can I say that this is a primary key, right? Primary keys means what? Which is going to identify the entire table values inequally. So which will indirectly saying that it is a kind of functional dependency. Right, fine. So with this example, can I say S name determines S department in this particular scenario? In this particular scenario, is S name determines S department? Yes. Why? All are unique names. All are unique names, right? Yes. So this is also valid. But the thing is, when you are going to define, so this is okay, ma. But the important point is, when you are going to define any kind of functional dependencies, you should not concentrate on the relation instance, right? Here we are trying to say in terms of relation instance, but you have to say in terms of with respect to the client requirement. In terms of with respect to client requirement, right? So basically, with the help of relation instance, we can define. So maximum extent it is correct, but sometimes it may not correct when you are going to say with respect to client requirement. The simple example is this one only, right? Student name determines S department actually in this particular instance, but generally there are certain students whose name is same. At this situation, now also it is correct. Assume that there is no K, there is J. Now in this situation, it is invalid. So student name doesn't derive HOD. Right? That is the case, right? So when you are going to observe when you are going to observe any kind of functional dependencies, you can able to split the table into multiple tables. That is what, right? You have identified S department determines SHOD, S department determines phone number. That's why I created one new table based on the splitting of the existing table. So that's the reason we got this table as my outcome. Right? So what you have to observe here, you have to identify that when you are going to identify any kind of a functional dependency, so try to create new table and place all those in the new table. That's it. Right? So let's see few examples. How can we say whether they are functional dependent or not? Right? For example, let us take. I am giving some naming here. Numbering. Right? Define the first one is name determines phone number, or is phone number is functionally dependent on name? No, right? The case is, if you are able to observe, A is occurred 2 times. If you are going to take out its right hand values, this is 1 and this is 5. So this is violating the property of functional dependency. So I can say that it is invalid functional dependency, meaning that it is not derivable. Right? Similarly, can you able to define phone number derives marks? Yes, it is valid because all are NEQ. Similarly, phone number derives name. Yes. Can you define marks derives phone number? No. The case is here 99, 99. So I cannot say that marks doesn't derive phone number. Like this, you have to identify various kind of functional dependencies, right? For example, what about the second table? So is A determines B? No. Is B determines A? No. Right? What about the third table? Is EID determines E name? No. The reason is 1 and 1 are there on like left hand side, on the right hand side both are different, so it is invalid. Similarly, is E name is going to derive EID? No. Right? Similarly, take out the fourth table. Like for example, try to take out any case. Can you define? Is A derives B? Is A derives B? No. Sure. Is A derives C? Yes. Because if you are going to take the value of A, the outcome is D. Value of A, outcome is D. Value of B, C. Value of B, C. Value of B, C. BC, right? So now at this particular situation, what you can do simply, can I split this table into multiple tables? Yes, right? So how can we do that? Try to split, like when you are able to observe A determines C, make sure to create a new table with these values. A determines C. If I give the value of A, I can able to get the value of D. So I can take only one. If I give the value of B, I can able to get the value of C. So I can reduce like this. Right? Similarly, what about the existing table? It contains all the values, right? One is A, another one is B. AA, AB, BA, BB and BD. Right? At least we have to do some kind of redundancy or not. So that is the advantage of functional dependency, right? Similarly, guys, it's not only about a single column. So what is the meaning of primary key? A single column can act as a primary key, and sometimes combination also act as a primary key, right? So same thing, right? If you are going to take out any combination, okay, here itself we find out some functional dependency, there is no problem. For example, can I say AB determines C? Can I say AB determines C? Is it possible? Try to observe. If I am trying to say that AB, combination is AA, AB, BA, BB, BD. All are unique or different? Unique. When I say that all are unique, I can say that this is determinant. It is possible, meaning that, see, when you are going to consider any relation, if I am going to take any relation R of A comma B attributes, So how many functional dependencies are possible actually? So I can take, there is no attribute I am selecting, and single column, multi column, right? So I am trying to define like this. One is pi A B, right? I can able to define like functional dependency between pi and pi, meaning that I am not going to take anything. Similarly, I can write like this, means I can write like is pi determines pi and pi determines A, pi determines B. Similarly, A determines pi, A determines A determines B, B determines pi, B determines A, and B determines B. Right? Meaning that what I have written here, I have written all possible functional dependencies. I have written all possible, but in this I can say that all functional dependencies are not valid functional dependencies. Am I right? Yes. See, if I say that A determines pi, is it a valid functional dependency? No, it is invalid. Right? So, if I say that any particular attribute can determine something, right? So, is A determines A? Yes. Is B determines B? Yes. Is A determines B? Maybe possible. Is B determines A? Maybe possible. And all the remaining things may not be true always. Right? So, thing is here, I can say them as basically as different types. One is trivial functional dependencies. Another kind of thing is non-trivial functional dependencies. Another kind of thing is semi-trivial functional dependencies. Semi-trivial functional dependencies. If I am trying to say that trivial functional dependencies, the meaning is, if I am trying to say x determines y, when I can say that this is a trivial functional dependency, means y should be a subset of x. I can say that this is a trivial functional dependency, or I can say that x intersection y is equal to y, right? Is there any necessary or is there an advantage of trivial functional dependencies? If you look into the examples here, can I write directly as A determines A? Yes or no? But is there an advantage? Everything itself is it determined, right? So if I am going to give A, can I get the value of A? Yes. So that means there is no advantage of trivial functional dependencies. So you need to always concentrate on non-trivial functional dependencies. That is what I would like to explain here. So no need to concentrate on trivial functional dependencies. What is the meaning of non-trivial? If I say that a function dependency x determines y, x intersection y should be pi, empty, right? Means if I am saying that A determines B, so is it a non-trivial or trivial? Non-trivial, because A intersection B is equal to pi. That's why we are going to concentrate only on this kind of functional dependencies. Okay, fine. What about the semi-trivial functional dependencies? If I am going to say that kx determines ky, and the intersection of these two is going to lead to some common attribute k, but not ky. If I am going to get ky, what will happen? It is trivial, right? If I am going to get this thing, I can call it as semi-trivial functional dependencies, right? So the point here is you have to always concentrate on non-trivial functional dependencies. Okay, means guys here actually what will happen? Client will give certain kind of requirements, right? From those requirements you are going to identify various kind of attributes. From these attributes, with the help of your illusion, you can able to identify various kind of functional dependencies. Right? I can call this as set of functional dependencies as F1. set of functional dependencies is F1, right? So those are all I am writing here. Try to observe. If you are able to do for this, for the fifth one, see, not only these two, for fourth one, not only these two, can you able to derive the remaining things? Is it possible or not? The way that we have written here, for 2, you got 9 possibilities of functional dependencies. Similarly, here also you have to check for all the possible cases. Okay, fine. Similarly, for the fifth one, what are the possibilities are there? Can X determines Y? No. A determine A, D, A, E. Here itself it is going to fail, so it is not possible. Can I say that XY determines Z? Yes, it is possible. XY itself is unique one, so I can say that XY determines Z. XY determines Z. Similarly, is Z determines Y? Yes, it is possible. You can check. Is YZ determines X? Okay. Just check with Z determines Y or not. Right? So if you take here BD, C is duplicate here, C determines C and C determines F. So Z determines Y is not possible. Y determines Z, right? Okay. Y determines Z. YZ determines X. Yes, it is possible because all are unique. So like this, you can able to do for all other things, right? So what you can do now, I will try to write out the cases. For example, let me take again XZ determines X, XY determines Z, X determines Y, Y determines Z. Let me take Y determines X, right? So you can check for the coming class, right, whether these are possible or not. Similarly, for the seventh one, A determines B, BC determines A, B determines C, AC determines B. Similarly, here A determines B, B determines C. Okay. For the coming class, try to check whether all this possible or not. Okay, fine. So guys, here what we are trying to do, when the client is giving the requirements, we are going to identify various kind of attributes. From those attributes, with the help of our illusion, we can able to find out set of functional dependencies, so that we can able to reduce some redundancy. But certain times there where you cannot able to identify the relationship between some kind of attributes, those attributes are also will be comes under the functional dependencies only. We can call them as additional functional dependencies. Is it possible to generate any kind of some other functional dependencies? See, as for the examples concept here, I tried to write only these few functional dependencies. But is there any other functional dependencies are possible? Yes, we can call them simply as additional functional dependencies. Right? So, is it possible or not? Yes, it is possible. So, but what you have to do? You have to write for all possible cases. Right? As like I have written here, for only 2 attributes I have written 9 cases. So here also you have to write all the remaining cases, right? So trying to write all the remaining cases is going to be a hectic task for you. Am I right? So for that reason, what you can do now, in order to find out the set of additional functional dependencies, you can go with some kind of mathematical formulas, right? In discrete mathematics, you have seen a kind of thing called inference rules. Inference rules means what? If I say that one statement is true, from that statement can you able to derive another statement? Right? If I say that A determines B, and if I am going to say that B determines C, can I say that or can I infer that A determines C? Yes. But there are certain situations in the database where you cannot able to identify the relationship between A and C. These are indirectly related, so that kind of relationship we can able to find out with the help of these inference rules, right? We can write it as inference rules. So first kind of inference rule is transitive inference rule. transitive. What is the meaning of this one? If A is determines B and B determines C, then A determines C. Similarly, union rule is there, right? If I am saying that A determines B and A determines C, I can infer that A determines BC. A determines BC. Similarly, decomposition is there. Decomposition. A determines BC. I can write it as A determines B or A determines C. What is the meaning of A functional determines BC? I can able to determine either B or C. Right? Similarly, reflexive rule. Reflexive means if I am trying to say that A determines B, then B is a subset of A. I can call it as reflexive. Right? Similarly, augmentation rule is there. If I am going to have A determines B, on both sides I can able to add a new attribute. I can call it as augmentation rule. Then also it is functionally determined. Functionally determined. Similarly, pseudo transitive rule. Pseudo transitive rule. Pseudo transitive rule means if I am saying that A determines B, and CA determines D, can I substitute in place of A B? Then I can say that CB determines D. This is what the meaning of pseudo transitive rule. Pseudo transitive rule, right? So based on these inference rules, can I able to identify various kind of set of additional functional dependencies? I can call them as F2, which I cannot able to identify directly, right? So for example, try to take out the case. If I am saying that XY determines Z, can I directly write as X determines Z and Y determines Z? No. Is there any inference rules I have given? No, it is not at all correct, right? It is not possible. Or is there any things are possible? This one with one 8th example, right? If I say that A determines B and B determines C, first these two are correct or not, you have to check. Is A determines B? Yes, possible. Is B determines C? No, these two are not possible. So then I cannot say that A determines C. Like this, you can able to infer various kind of functional dependencies, right? Yes. But the problem here is, try to take out the example. For example, A determines B. A determines B. B determines C. DE determines F. F determines GH. H determines K. Right? Assume that these are the set of functional dependencies I have written with the help of my basic knowledge. I can call it as F1. Now try to find out the set of functional dependencies which you can able to find out with the help of your knowledge. Can I write as A determines C? Yes, A determines C is possible. DE determines, very good. Another possible? F determines GK. F determines GK, very good. Right? So like this you can able to write many kind of things. Right? You have to apply various kind of formulas, right? Means what you can do, can I write F determines K? You haven't answered, right? So almost all 60 people are there, but nobody answered F determines K, which means that with the help of simple inference rules also, I cannot able to get all kind of additional functional dependencies. It is not possible. Means sometimes we may miss, or sometimes it may lead to error prone. Am I right? So the problem with this one is error prone, or sometimes you may miss the set of additional functional dependencies also, right? So how you got f determines k, right? So observe here, can I write like f determines gh as f determines g, f determines h. If I say that f determines h determines k, can I write as f determines k? Yes. So like this you have to go through in depth, right? So that's the reason inference rules are very hectic task for us, right? So to overcome this drawback, we are moving for one kind of another concept called closure set of FDs. Closure set of FDs. Okay. So what is the meaning of closure set of FDs? Right? So if you are going to take any functional dependency, like for example, I will try to take with the example first. If I am going to have a set of functional dependencies as A determines B, B determines C, C determines D, D determines E. This is my set of functional dependencies F1. Now can you able to find out any additional functional dependencies? Right, basically with the help of inference rules it is possible for you, right? Basically, right? So there is a transitive rule, A determines C is one possibility, A determines D is one possibility, and A determines A is also one possibility, right? So based on inference rules you can able to, as it is simple one, right? In another way is I can able to go with the closure set of functional dependencies. What is the meaning of this one is, if I would like to find out what are the functional dependencies that are possible for the A, then I can say that it has closure of A. Closure of A, I can represent it technically as A plus. A plus. If I want to find out A plus, what you can do now? So basically, is A functional determines A? Is A functional determines A or not? Everything is functional determines itself. So I can call it as trivial functional dependency. Now with this A, can I able to determine any other functional dependencies? Try to observe in the given functional dependency. Is A determines B? Yes. Then you can simply add it to the same location, AB. Now with either A or with B, can you able to define any other functional dependencies? Yes. So B derives C. So I can write as A, B, C. Now can I write the same thing? A, B, C, D. So means A plus means I can write as A, B, C. Means the meaning is A functionally determines A, B, C, or A determines B, C, D. Can I write like this? According to the rule of decomposition, if I say that A determines C, D, A determines C, or A determines D. So now what is the meaning of this one? If I am trying to say this one, the meaning is it can able to, meaning that A determines either B or C or D, or what? BC, BD or CD, or possibility is BCD only, right? These are all the possibilities you may get, right? As it is the first example I am trying to define. What is the meaning of this one? I can able to determine either B or C or D or BC, BD or CD or entire BC. That's the meaning of this one, right? So basically what you can do now, in textbooks you can observe it has some different meaning. So if I would like to find out the closure of B, can you tell the closure of B? Closure of B I can write as B plus. So basically what they will do now, every closure of B itself, B is possible, that they are going to assign it a variable called X, right? A variable called X, and they are going to do the same thing again and again, right? If I know the B, what I can able to find out? Can I able to find out C? So I can able to find out C. If I know C, can I do D? Can I do BCD? X equal to BCD. So X means it's simply B plus. So meaning that B determines CDA. I don't need to write BCDA because it will internally defines as B determines B, right? So that is the concept of closure set of functional dependencies, right? Now with the help of a single sort, can I able to determine what are the functional dependencies that are possible with respect to A or not? That's the advantage of closure set of functional dependencies. Okay, fine. So try to do the next one. For example, if I say there is a relation R of which contains the attributes are there, and the given functional dependencies are A determines B, BC determines DE, AEG determines G. Can you find out the set of other functional dependencies are possible? Other functional dependencies possible for A. So compute the closure of A, right? What other functional dependencies are possible for A, that you have to find, right? So for that, what you can do, you have to find out the closure of A. What is closure of A? A. From A I will get AB. Is there other things are possible? No, nothing is possible. Am I right? Yes. Similarly, can you able to find out the closure of B? B itself is B. Anything is possible? No. B doesn't determine any other functional dependency. Similarly, try to find out for the C plus, which is C, D plus D, E plus E, F plus F, G plus is G. Next level is you have to go with AB plus and AC plus. Like this, you have to find out all the kind of cases. But generality, what they will do now? They will try to give one particular thing. Try to find out the closure of AC. That's it. They won't ask for you to find all the things. But these particular things are required when you are going to find out the other important concept that I will explain in the later part. So for time being, try to find out the AC plus. So you will get itself one is AC. From A, can you able to get B? Yes. So can I write like ABC? Yes or no? Yes. What about the next one? Can I write BC? Can I write like DE? A, B, C, D. Right? If I know AE, can I write G? Is there other kind of extensions possible here? No. This itself is possible. That's it. You cannot able. So, which means that AC can determine B, D, E. BD. What do I mean this one? AC cannot able to determine G, or AC cannot able to determine F. That you have to understand, right? So what I have done here, can you tell in the form of an algorithm? Algorithm for closure set of attributes. Can you define? What is the first step I did? Basically, I have taken one variable x. Step 1, I have taken one variable x. I made it equate to x. Right? So means I need to take one attribute x that I need equate it to the closure attribute. This is first step I did, right? So that is what, right? If I want to find out closure of A plus, what I did, I have taken x and that I equated with the corresponding closure attribute, right? Next, what about the step 2? I have taken FDs, right? So I have taken all the FDs one by one, and I am going to check whether the left side of the FD is a subset of the X or not. right? Meaning that I am going to take one by one FDs and trying to check left side of FD is subset of X or not, subset of X or not. If it is subset of X, what I am going to do? I am going to make the right side part union to the X. Is it okay? Right side part union to the X, right? Unless the condition is what? Unless right side is not a subset of again X. Am I right? If I am saying that the right side is already existed, why again need to add? Why again need to add? No need, right? See, let me take the example, right? So if you take out any other thing, what I can call, if I take A determines B, C, if I take A determines B, C, I want to find out ABC closure. I want to find out ABC closure. What you have to do? You are going to take the ABC itself, and I am going to take out one by one FD, and I am going to check is it a subset of this or not. Yes, it is subset. Then I need to include the right side part on the X, right? That means X union right side. But when you are going to add, if right side part also not there in the X, that's what I have written. Right side part is not a subset of X. That's what, right? Next, this process you have to continue. So you have to repeat the step 2, and finally your result will be the answer, right? So you can stop and you can make it as the set of FDs positive. That's it. So I can write it as if you are not able to add, any other attributes, then you can stop it and we can say that the set of FD is possible with respect to X or like that. This is the general algorithm to find out closed set of attributes. Okay, so let's try to solve few questions regarding this concept. Like for example, there is a function, set of functional dependencies are F1. Those functional dependencies are A determines BC, CD determines E, B determines D, and E determines A, right? And the relation R of A, B, C, D, right? So try to find out any other thing, right? For example, compute ACD plus. Please try to find out the closure of ACD. So first you are going to take out X, which is equal to ACD. Next from A, what you can able to get? You can able to get BC, C already there, so I don't need to add, right? Next from CD can able to derive E? Yes, A, B, C, D, E, right? I think already all reach, right? All reach, so we can able to stop the process here. So means ACD can derive B. This is one kind of functional dependency or possible. Okay, so try to take out another case. For example, A determines BC, or else let me take only the same example. Can you able to compute the closure of AD closure? AD closure, X equal to AD, A determines BCD, CD determines E, C determines C. See guys, if you are able to observe, I think it is covered everything. If you observe, the meaning of this one is, if I am going to give AD, which can able to determine the entire the set of column, set of all the tuples, set of all the column. What is the meaning of this one? Can I consider ACD as one primary key? Yes. Can I consider AD as one primary key? Yes. That is the meaning of this one. Meaning that if you are going to find out the closure set of any particular attribute, if it determines all the attributes of the table, then I can call it as a primary key. Primary key. Generally, if a table contains more than one primary key, all primary keys I will call it as candidate keys. Right? Multiple primary keys may exist. So all those keys I can call it as a candidate keys. Among those, one kind of key I will call it as primary key. So I hope you know the difference between the candidate key and primary key now. Meaning that which is having less number of attributes I can call it as primary key, and all the remaining things I will call it as candidate key. Right? Now assume that ACD and AD are the candidate keys. Which one you are going to take it as primary key? AD. So 5 minutes of the point. You can take it as primary key. Primary key, right? So take out this example. For example, if I am going to take the functional dependency, A determines BC, and CD determines E determines C, D determines AEH, ABH determines BD, DH determines BC. Assume that this is a kind of function 1, set of ones, and the relation F, G, H. Right? So can you able to define is BCD determines H? So what you can do for this? You have to find out the closure of BCD. BCD closure. Right? So if you are able to find out BCD, what you can do next time? From CD, can I get E? Yes. Then, is there any possibility to replace D with some values? Yes. Right. If I am going to replace with D with some value, you are going to get AEH. A is already there. E is already there. I can write as H and E. Right. Which means that BCD can able to derive H. So BCD determines H is possible. Means, so with help of closure set of attributes, we are going to have various kind of advantages. So among those, what is the first advantage? Can you able to find out the set of additional functional dependencies? The first and foremost advantage is set of additional functional dependencies. What is the meaning of total functional dependencies? The functional dependencies which you find out during the first step, and the functional dependencies which you are able to find out the additional functional dependencies. I can call them as total functional dependencies. And the other advantage of closed set of attributes is, which is meant for to define two functional dependency sets are equivalence or not. So equivalence of functional dependencies we can able to define. The other one is you can able to identify various kind of candidate keys. You can able to identify various kind of irreducible set of functional dependencies. Irreducible set of functional dependencies. Irreducible set of functional dependencies, right? These are the, right, I can able to call the irreducible set of functional dependencies as standard form of FT sum. Standard form of FTs, or I can call it as canonical form of FTs, right? So I hope you know how to find out the set of additional functional dependencies, right? So in the coming class we will try to see all the remaining three. Okay, fine. So we'll stop here. We'll continue in the next class.